This video will follow the experimental setup section of the 112 pp user guide. In this video, we will show how to prepare the system for experimentation. We will also do tissue dissection and mounting. We will show a brief wake-up protocol, and lastly, a few agonist responses. In order to prepare the chamber and system for use, we will first fill the P1 bottle with our PSS buffer. You should not add more than 250 milliliters of buffer, as this can affect how the bottle pressurizes. Next, you should add the calibration shunt as if you were going to do a pressure calibration. We'll use the Myograph software to set the pressures, which will fill the lines and will also fill the pulsation wells on the chamber. We will set P1 to 150 and P2 to 50. We'll turn on pressure and make sure that flow is also turned on. While the lines are filling, you can use a syringe to fill the chamber with your PSS buffer. We will first open the P1 bleed valve, which will start to fill this chamber. Once the liquid has covered the entire bottom, we can close that quickly. We'll now close that. We will now close P1 and we will open the P2 valve. After the P2 is filled, we will close that as well, and we can turn off flow and pressure. We should now remove the calibration shunt and fill the cannula lines with buffer. Since we now have liquid in all the lines except for the cannula lines, we will use our syringe with our PSS and push all the air out of these lines. You can see when all the air bubbles have been pushed out. Then you can reconnect your tubings. You should close the two three-way valves towards the chamber, and you can now disconnect your tubing and interface chamber cable in order to take the chamber to the microscope for mounting. For our purposes today, we'll be using a mesenteric artery. The mesentery is a good tissue bed to use, as there are many vessels that can be used as practice. Pin out a section of the mesentery. You will start by cleaning away the excess tissue. Take care not to touch the vessel with your forceps. Avoid any branches at all costs. Cleaning away excess tissue is more important for pressure experiments than it is for the wire. After removing the excess tissue, you will see the artery and the vein side by side. It is important to identify the artery, which has thicker walls, a smaller lumen, and will appear more white. The vein will often appear more red as long as blood is still in the vessels. You want to add as little stress as possible to the artery. You can cut away the vein. Now isolate the artery. You can place the clean vessel in a small container of cold PSS. You can now fill the 112 pp with cold PSS. Make sure that your cannulas are aligned and at the same height. Place two double knotted sutures on each cannula. Carefully transfer the vessel to the 112 pp chamber. It is best to use a large bore pipette tip and a pipette, or an eyedropper to transfer the vessel and minimize vessel handling. Carefully mount the P1 side. If you are doing a flow experiment, it is important that the P1 side is the upstream or the proximal side. You can use two different cuts to distinguish a straight cut and an angled cut. Any part of the vessel that touches the cannulas will be damaged. So you will add your sutures towards the tip, but not too close. Once you have the P1 side mounted and secured, you can use a syringe with tubing attached to the P1 three-way valve. You want to make sure that you do not introduce any air into the chamber. Then you can push some buffer through the vessel and you can remove all of the blood from the lumen. This will also help open the distal end. You can then close the three-way valve. Switch to the P2 side and move the P1 cannula so your vessel is at the optimal distance for mounting on the P2 side. Slide the vessel onto the P2 cannula. Secure it with the two sutures. You can open the P1 side and add a small amount of pressure. The vessel should bulge and you should take note of the shape that it makes. Close the three-way valve while the vessel is still under pressure. If the vessel holds its shape and pressure, you know that you do not have a pressure leak and the vessel is good to go for the experiment. Cut and remove the ends of the sutures and transfer to the microscope. Now that the vessel has been mounted, we will immediately start bubbling our buffer and turn on heat. We will turn on pressure and we will start to get a better, cleaner image for our wall tracking. Start with P1 and P2 both at 10. You can start data collection at any point. Some users will start it after the initial pressure stretching. Some will like to collect this data as well. We can increase to 30 millimeters of mercury. And since flow is off, only P1 target pressure matters. We will see our vessel is starting to distend. You can use the X direction manipulator to begin to stretch your vessel. We will now go to 70. The final pressure step we will check and stretch our tissue is at 110. The highest pressure we will go to is 110 millimeters of mercury. Once you have reached this target pressure, you can then stretch your vessel to the desired level of stretch. You can monitor this using the force transducer on the 112. We will draw a box over the vessel that we want to image and make sure we are getting good readings on the walls, and we can start our data collection. You can see how the Myograph software is picking up the walls using the image on the right. You are also free to move the box around or resize the box by using the adjustments. We will now start data collection. You have the ability to look at any number of parameters collected from either the chamber, the interface, or the Myograph software and camera. You can also record up to 4 locations along your vessel. We will be viewing inner diameter, but all other parameters will be recorded in the background. We will now wait 20 minutes for the heat to warm up, as well as to let the vessel sit in its new environment. This is the first step of the wake-up protocol. After 20 minutes, you should do a washout. You will remove all the buffer from the chamber and replace that with fresh, warmed, aerated PSS. After 40 total minutes, repeat the wash, remove the old buffer, and replace with fresh, warmed, aerated PSS. Once a total of 60 minutes has passed, the wake-up protocol or standard start protocol can be initiated. After the tissue has been isolated from the animal and dissection has occurred in cold PSS, the tissue needs to be activated or woken up to get proper contractions and responses during the experiment. In order to accomplish this, we will perform a couple of contractions using high potassium PSS. You can also use noradrenaline to activate other pathways. This is just one example of a wake-up protocol. The high potassium PSS should give you a good contraction that is easily seen but is also easily washed out. Give an exposure of 3 minutes and then perform 3 PSS washouts over 5 minutes. After we've performed the 3 washes, we will now do a second exposure to KPSS. We will make a comment and we will start the exposure. We will now briefly show the pulsation feature of the 112. You can set the pulsation from anywhere from 50 beats per minute to 600 beats per minute. Before we do our agonist responses, we will set our vessel to 60 millimeters of mercury. We will start by doing contractions with phenylephrine. In response to acetylcholine, you can see the relaxation returning close to baseline. During a normal, full experiment, you will do additional doses, various concentrations, of your contraction and relaxation agents. But this will conclude today's test. For more information on the 112 pp, please refer to the DMT website or additional training videos.